Dr. Füsun Tut Halkidir. Hello there. This way, it's better. Welcome. Thank you very much indeed. Nikos Sofianos. It's better to be here, not... this one. And Dr. Iskander Gökalp. And of course, our friend Dr. Nicholas Koukos is going to be online. Nicola, can you hear me? All right, let's start. Okay, I'll have few things to say just as an introduction, and then I'll give the floor to the distinguished. Okay. This is the last session. Usually, ENA has energy efficiency in the end. It's last, but I believe for the majority of you is not least. Ladies and gentlemen, energy efficiency and renewables are said and proved to be the main pillars for EU policies towards energy transition and energy crisis. Greece and Turkey are both committed to work hard in the next coming years to fulfill energy transition's goals, minimizing their greenhouse gases to a net zero level by 2050-2053, respectively. We all know that final energy consumption in the following three sectors is responsible for the greenhouse gases: building sector, transportation, and industrial sector. Regarding the building sector, I have some data to share with you. In EU 27, there are 24 billion square meter permanently occupied floor areas. 42% of the total final energy consumed in Europe 27 is in building sector. 23 of the emissions are for building sector. 70% of the 24 billion, that means about 17 billion square meters, are in the residential sector. 85% of the existing EU dwellings were built before 2000, and 85 of them will stay until 2050. They found that 75% of the building sector has poor energy performance. This means that we have quite a lot of work to do, and only 1% per year is deeply renovated. Regarding Turkey, very few data and information I'm going to give you. We have the expert here to give us more. A high rate of urbanization, reaching 2% per year, is noted, and this urbanization leads to a fast-growing building stock of construction rates of 4 and 4+%, contributing to 6.6% of real gross domestic product growth. Residential sector, 2015, the data that I found is 2.4 billion square meters, and expected to be more than 4 billion in 2050. So you understand that we have serious things regarding at least the building sector. EU directives referring to energy efficiency and to energy performance of buildings and their recast, and also the directives for new technologies for fuel as hydrogen, are transposed to the legal framework of both our countries. Note that A deep energy renovation in public buildings required by the Energy Efficiency Directive started in both countries, referring to hospitals, hotels, schools, and so on, as the main energy policy to improve public building stock. Concluding, in our session, all the above issues and more will be discussed with a distinguished panel with attention to energy poverty and to renewables suitable to assist buildings to be improved, they provide thermal comfort as geothermal energy and required in deep renovations. I'm concluding these short notes that I'm telling you with the motto adopted by EU, energy efficiency first. So, I have the pleasure to ask Mr. Sofianos to come here and to give his presentation. Thank you.
If you can upload my presentation, please. Thank you very much. So, good evening, everybody. Mr. Chairman, dear delegates, my presentation will be on energy poverty in our region. Energy poverty. Well, in relation to energy transition, of course, and always, we decided to make a reference to energy poverty because sometimes it makes no sense to focus our attention on energy transition issues and to these beautiful things about the RES development if we do not first pay attention to one of the main problems of the region, which is the energy poverty. So, energy poverty exists. It's something real. The problem is to measure it. The problem is that energy poverty, the measurement of energy poverty, is something subjective. And furthermore, we do not have a definition acceptable from all the parties, from all the countries. So EU accepts four indicators, let's say, for causes of energy poverty. The first is the high proportion of household expenditure spent on energy. Sometimes they say that if you spend more than 15% of your income to energy expenses, then there is a problem. But actually, in European Union, many households spend more than 20% of their income to energy bills, to utility bills, and transportation costs. Arrears on energy bills, the delay to pay the bills, low energy performance of buildings and appliances, inability to keep home adequately warm or cool. Well, those two images are from North Macedonia, but you can find these conditions, this situation, also in other parts of our region, for example, in Albania, in Bosnia-Herzegovina, in Kosovo, even in Serbia and Bulgaria. So energy poverty is a multidimensional problem. And as you see, the absolute poverty goes beyond high energy bills for people. Energy poverty for those people, for these countries and for these conditions means that a household does not have a sufficient access to modern energy services and technologies. Of course, there is poverty, energy poverty also in Europe. Between 50 and 125 million Europeans are estimated to be affected by energy poverty. And in 2022, 40 million people were unable to heat properly their home. The problem, of course, is most visible in Central Europe, in Eastern Europe, and in Southeastern Europe. In our region, it is estimated that 30% of households are struggling with energy poverty. Now, this diagram is very interesting. Okay, the map shows the correlation between the energy poverty and the inability to keep home adequately warm. But the diagram is more interesting because you can see in the blue line, in 2015, the problem was most severe in countries like Greece, like Cyprus, like Lithuania, like Portugal. But in 2020, you can see a very sharp decrease. Why? Because the people of this country, they took advantage of the European funds in order to invest in energy efficiency programs. So this diagram shows exactly the correlation between the investment in energy efficiency and the alleviation, let's say, to this energy poverty domain. Now, another indicator, a very important measure, is the indicator showing the poor living conditions. And analyzing this data, it can be seen that the highest percentage of people living in poor condition are in countries such as Cyprus, Turkey, and Portugal. The arrears on utility bills. Well, as you can see, Greece is a champion on delays. In 2020, the delays, the arrears, were about more than 25% of the population. And the newest data show the arrears in Greece about 28, 29, almost 30% in 2022, 2023. But as you can see, the problem is common in the south of Europe. Well, energy poverty is not only, of course, the four above indicators. It's also the environmental degradation, it's the air pollution. And you can see here the 16 coal power plants in the Western Balkans that cause as much pollution as the 250 plants within the European Union. The health impact is very severe, and not just within the region, as you can see how it affects the wider region. 8 of the 10 most polluting installations in Europe are found in the Western Balkans. Kostolac B and Uljevik in Bosnia and Herzegovina produce a quarter of all sulfur dioxide emitted by all coal plants throughout the continent. In 2021, the dust emissions from coal plants in Bosnia and Herzegovina, Kosovo, North Macedonia, and Serbia increased compared to previous year, 16 more times as much as allowed from the standards of the European Union. And my last frame is that one, the correlation, the relation between the energy poverty and the energy transition. And the question is if energy transition can help to alleviate the energy poverty. The question is that the answer is that we don't exactly know, and it is not there is no any proof that energy transition can in short term or even in medium term alleviate this result. Of course, to substitute coal plants with renewable energy sources can bring better air qualities. But as you can see, the red is the red bullet points showing how energy transition can accelerate actually the energy poverty. So the conclusion is that we must have a joint discussion related to energy poverty and energy transition. Energy transition strategies and policies should not be considered separately. Energy poverty is a neurologic a critical part of the energy transition. And if we want to form efficient policies and strategies toward the energy transition, these policies must pass through the energy poverty issues. Thank you very much.
Thank you very much, Mr. Sofianos. I noticed that in your presentation, you are mainly focused on heating period. Is that true?
Yes.
With the climate change and the high temperatures during summertime, we are also facing.
Then there will be a problem for the cooling.
Yes, that I'm saying. That means so that energy poverty is getting bigger and bigger all the time.
The indicator is not only the heating, but also the cooling.
Yeah, okay. Thank you. Now, I have the pleasure to ask Dr. Auguste Kahn. He's the chairman of the Energy Efficiency Association and COO Texan. Take the floor. Thank you very much.
Hi, everybody. Thank you very much for your introduction, Chairman. Actually, while I was passing through the Bosphorus Bridge, I see the reddish, dusty sky. And I seen the same sky in the social media in Athens. So, and also we have presentation about solar PVs and wind energies. We are within the same region that the same wind is blowing through us. And we are under the same sun. And we are neighbor to each other, so which means that the African dust is impacting us, which means that we are too much closer to each other time to time. We may, let's say, confess and to touch to this issue. Even with Africa, we are living in a very small town, so-called world. So COVID also, pandemic, has been shown that from the long distance, we are easily impacting in a few days. So we are living within the same territory, within the same border. That's why we need to save the world. We need to save the, let's say, environment. As Kostas, our chair, said that energy is the first fuel. Actually, IEA is using, Fatih Birol is using this, let's say, definition. I like it very much. Energy efficiency is the first fuel, actually. And he mentioned about the buildings. And my colleagues from Nicholas from Greece is mentioned about the energy poverty, so is another things. So this is increasing the, let's say, importance of the energy efficiency, both in terms of the environment and the sustainability of the business, sustainability of the, let's say, of the world. So I'm going to mention about, without presentation, just to mention about what we are doing in Turkey. I'm representing the Energy Efficiency Association. Very shortly has been established in 2008. Immediately after the, let's say, the main regulation of the Energy Efficiency Law, which was in 2007. The Energy Efficiency Association is the roof association specifically targeting the energy efficiency. In Turkey, yes, there is a big challenge. As Kostas mentioned, that 43%, you said, Kostas, is that consumed by the building. I can give some figures from Turkey that 20% of the, let's say, final energy consumption is coming from the residential buildings, and almost 11% from the commercial and service buildings. So which means 31% of the energy of Turkey has been consumed in the, let's say, building sector, 32, 33 in the industry sector, 26 in transportation, 4% is agriculture, and 6% is the other, let's say, energy outer the energy consumption. Similar to, let's say, emissions is coming from these sectors. We can say that the carbon dioxide emission sector is mainly coming from the energy usage. Not 80% like in Europe, but 74, 76% 6% of the emission of the Turkish inventory in the emission is coming from the energy usage mainly. What we should do, yes, energy transformation and energy transition is a must, and we are living in the middle of this transition. Maybe our Professor Iskender Bey is mentioned about what we're gonna do, surplus renewable energy, power to X, hydrogen. So this is the one of the things. We talk a little bit about the storage. We talk, let's say, in detail in the wind energy, solar, geothermal is coming, maybe this. But all these, let's say, reduction of footprints. Footprints is a little bit negative. Footprints is negative impact on the carbon dioxide, footprint of water, footprint of, let's say, waste. But what we are going to do with energy efficiency, we're gonna improve our handprints. So we put a positive impact on the, let's say, environment and energy. So energy efficiency first, not the reducing of the, let's say, negative, but maybe increasing of the, let's say, business as usual. That's the one thing. Without energy efficiency, there is no way to go to carbon neutral or net zero carbon. Turkey is addressing that 2053, the target year that's gonna be carbon net zero, let's say, country. So that's, so, which means that energy efficiency is no more last and least, but is one of the main, let's say, challenging area. I should address maybe at the last, but just I'm having the right to floor to touch that. Energy efficiency is difficult than wind energy. Energy efficiency is difficult than the photovoltaic because it requires multidisciplinary, multi-stakeholder, and focus, let's say, challenge and, let's say, efforts to accomplish the targets. The targets are important, as we see that Europe is very good at establishing of the targets and also, let's say, enhancing with the mottos. Turkey is also did a very good energy efficiency planning in the 2017. I'm proud of that. I was the part of this, that's the first national energy efficiency plan. So it was the period of 2017 to 2023. This is the first national energy efficiency national plan was addressing, let's say, $8.4 billion investment, no, sorry, $10.9 billion investment. The realization is $7.4 billion. 40% of the energy efficiency in the primary energy. This target also has been accomplished. 24.6 million tons equivalent of oil energy reduction is above the, let's say, target has been accomplished, and 60 million tons of carbon dioxide emission abatement, 68.62 million tons of carbon dioxide emission reduced. So there is a good example, good, let's say, practices from Turkey that Turkey has made a good planning and implementation. By the way, 44,880 green employment has been realized. So that's the result of the first national energy efficiency plan. With this, let's say, momentum from the IEA report that we are seeing that there's an appraisal about Turkey 2 consecutive years, 2021 and 2022. There's a two country, the most, let's say, energy efficient country. One is Turkey with the 6.2% energy density drop in 2022. So this is also good outcomes of the efficiency plan. So what Turkey has did, having this momentum, the second national energy efficiency plan immediately after implemented and, let's say, started. So the second national energy efficiency action plan is addressing 16% energy efficiency in the primary energy, $20.2 billion investment, and up to 2040, $46 billion savings. So energy efficiency, by the way, is very good investment, and return on investment is, let's say, if you do a good planning, let's say, is a very high if you look at from the investor point of view. Public buildings, because Costa said me that please make a pressure on buildings, so that's why I'm touching the subject again. There's a special, let's say, chapter about the buildings, of course, because as we said, 31% has been consumed in the buildings. It was 15% energy efficiency in the first energy national plan. Now it's 30% in the, especially in the public buildings by 2030, which means that $700 million investment is going to be in the investment. Because otherwise you are heating the air, you are trying to, in the winter, you are trying to cooling the air in the summer. Since 2015, by the way, in Turkey, the peak demand is occurring in the summer season. Before it was in the winter. Now we are seeing the climate change, and the air conditioning and cooling demand is increasing every year. So energy efficiency is one side is cost reduction, one side is helping to the supply security, low carbon economy transition, competitiveness, employment, green employment, as we said, and productivity and asset valorization. So which means that energy efficiency in the one side is, in terms of 360 sustainability impact, is very important. A few words about the Energy Efficiency Association, which is, I believe, that best practices, and we did how we can increase the awareness, because not only the, let's say, measures are important, but also behavioral change is very important. That's why Energy Efficiency Association has been, let's say, in a progress of 2019 and 2021, and also this year probably we will make the same measurement, or let's say questionnaire and face-to-face, let's say, public awareness and entities awareness. So this energy consciousness index or awareness index is also one of the best practice from Turkey that is a very in detail. There are almost 200 questions, and that graphic, sorry, in Turkish, by the way, but you can refer to our association to check it out. Let's say, tendencies and let's say, understanding not only the awareness, but also put into the practice what is going on. So we are measuring, we are also making some activities, and another, after 2 years, we are measuring what is the impact, how is the development. I can say that since 2019 to 2021, the Turkish, let's say, household energy efficiency awareness is around 163.8 points out of 200, which means that the awareness of our household people or our citizen is a medium-high level. But when we come into the practice, is dropping 140, so which is acceptable, expectable, but not acceptable. But in the meantime, for the legal entities, corporates in the, let's say, sectors like industry, like transportation, services, and agriculture, the awareness index is 166.3. So one also in the increasing trends. In the COP28 in UAE, has been accepted that energy efficiency efforts should be doubled. So which means that the average global energy efficiency is nowadays is 2% energy savings. As I said, Turkey did it 6.2 in the 2022, which is record of Turkey, which is record of the world. But in any case, increasing from 2% to 4% is not easy, because as I said, this is a multidisciplinary effort, but it's really increasing our headprint. So it's gonna save 7 gigaton of carbon dioxide and reduce the cost of buildings. Nicholas, you said that the poverty of the, let's say, households and energy bills, so which means that directly impacting to the household energy bills 1/3. So this is very important impact on the energy poverty. But also requires not only in the buildings, but transportation, which is even Europe couldn't reduce the emissions from the transportation. 5% of, let's say, efficient buildings every year should be on the way, from bigger passenger cars to the smaller, but we don't see such a trend, by the way. So the cars are becoming bigger, and the SUV cars are becoming more attractive nowadays. 30 to 40% less energy consumption in cooling with the efficient air conditioning and the household appliance. So this also requires not only the behavioral change, but also technology, thanks to them, let's say, helping us. Very last 2-3 statements. Renovation of buildings or isolation of buildings in the worldwide can, let's say, bring such a saving that the amount of the buildings in the China and India. So which means that energy efficiency is a huge potential in the worldwide. But last word, without behavioral change, such a, in the cooling 19 Celsius degree or 20 Celsius degree, such behavioral change is also have a big impact on these things. So that's the things I would like to address, just to make the, let's say, combination of the buildings and the energy poverty. We need to work much more continuous and, let's say, focus on those things. We require good engineering, good design, good implementation, and good operation. So that's the whole result of the energy efficiency. Thank you very much.
Thank you very much indeed, Dr. Khan. I've seen that there is a very vast experience with the association. It's almost now, we are going 16 years.
Yes.
Who is also participates in this association? I mean, let's say, for example, you have consultants. Probably, what are the members of this association? Just elaborate a little bit, because here in Greece we don't have it. Mm-hmm. So that's a very good idea to give us your lights, as they say, your thoughts. How can you do something that is very important? Because I've seen that, and you said it also, how much Turkey improved on energy efficiency with the percentages, highest in the world.
Yes, of course, energy efficiency requires, as I said, multi-stakeholders from the public, from the private sector, from the academia. So which means that I think in the first National Energy Efficiency Plan, there is a 55 action. Mm-hmm. In the second National Plan, there is above 61 action, 255 activities. So this is not only from the Minister of Energy, but also it's maybe 20, 30, let's say, governmental and private sector has been involved in these efforts. Returning back to the Energy Efficiency Association, which is established in 2008, as I said, is a roof of the specifically addressing the energy efficiency, has a combination of, let's say, board members from the, let's say, variety of sector, from the finance, from the business world to SİAD, MÜSİAD, from the energy distributors, including electricity, natural gas, and the petroleum, and academia, very, let's say, distinguished, let's say, professors and ladies is let's say, contributing a lot on this, let's say, activities. Of course, some from the governmental, let's say, peoples, as Ibrahim Erdem Bey said that in the Wind Energy Association, having such a governmental representative, not too much, maybe 1-2, is also helping to policy making, and also talking together with the business people and listen to each other under the NGO, non-governmental organization. This really helping to increase the, let's say,
so this association was done like the Wind Association by a decree of the government. Is that correct?
No, this is I mean, triggered by the government.
Triggered by the
By
government?
not with the
Oh,
decree.
okay,
This is
okay.
any other associations has been subject to the same law, not a specific law. So this has been triggered by the government, but with the help of the business, with the help of the academia, is increased and accelerated, I must say.
Thank you very much indeed. Now, I have the pleasure to invite Dr. Hüsnü Tut Haldikir, Geothermal Technologies Exploration and Innovation Group Manager of Zorlu Energy. Geothermal energy, where Turkey is very high in the world, I think.
Yeah.
And personally, I'm very fond of geothermal energy. It's user factor 99%, 98% compared to wind and photovoltaics.
Yeah.
So thank you very much.
Yes. Okay. Okay. Yes. Herkese merhabalar. Kalispera. And good afternoon, ladies and gentlemen. Today, I will mention about the geothermal energy potential in Turkey. But I know that it's a very long day, and I try to minimize my presentation. And I will just focus the most important part, and which related to both countries. Yes. Okay, many participants mentioned about the Turkey's energy outlook and our expectation around 65% renewables for 2035. It's a very nice numbers because especially wind and solar is quite important for order of the renewable energy in Turkey, but energy diversity is also important. We are mentioning about the energy efficiency, but energy diversity is also very important for all countries in the world. Sometimes geothermal energy is surprised us when we follow the governmental transparency platform, APH platform, to follow up the installed capacity versus the electricity production. Geothermal energy or geothermal power production, even it's lower than half of solar and wind, sometimes it looks very competitive. Of course, it depends on the climate conditions, and we can always, actually oftenly, meet such kind of extreme weather conditions, and we have no idea what will happen in future. That's why energy diversity is also quite important. And of course, when we check the geothermal energy capacity, geothermal power capacity maybe, of Turkey, we can see that it's fourth rank country in the world and the first country in Europe. This is nice. And of course, we work a lot to reach these capacities, but of course, the incentives are quite important. And many participants also mentioned about the renewable energy support mechanism in Turkey, especially between 2010 and 2020. We dramatically increasing geothermal and other renewable energy usage for electricity production. This was very important. But when we check our history, renewable energy history in geothermal energy and also renewables, we can see that some important steps to reach these capacities in Turkey. For geothermal, the first geothermal power plant is put in use 1984, and till 2006 there is no another geothermal power plant. Imagine that. No one interested at that time. And after some regulations like Renewable Energy Electricity Law and Geothermal Resources Law, the investors show interest because they understand some rules of the play in renewable energy and try to be part of this renewable energy industry. So, of course, renewable energy support mechanism change not mechanism, but incentives change almost each 5 years, and it affects our capacities too much. For example, near the COVID-19 period, the incentives, the previous incentive is finished. And what happened? It's almost stopped. The geothermal power production or new investments almost stopped because, yes, solar panel costs reduce, and maybe the capacity factors of the wind power system start to increase and reach to Bert's limits. But unfortunately, geothermal power plants and the equipment costs still same in new world. So we can see that the governmental incentives, how it's important. But the investors still show interest to geothermal power. Why? Because the capacity factors are still very high. When we compare the solar and wind, as you predict, the geothermal power production almost twice capacities and twice electricity production provide. It means that the installed capacities are quite important. But end of the day, we can understand that how much electricity we produce from these systems. Sometimes people still surprised and no idea about the capacity factors and the electricity production. So they say that, isn't it similar? No, it is not similar. So in geothermal potential of Turkey is very important for us because we can see everywhere the tectonic activities, and in both Western Anatolia and Eastern Anatolia we can see the volcanic activities. Of course, these are, some of them are sleeping volcanoes like Nemrut region in the Eastern Anatolia. And in Greece, when we visit the Greece and Greek island, we can also see same structure. And not only in islands like Lesbos and other islands and Chios, etc., we can also see some potential near Alexandropolis, for example, near Dede Ağaç in Turkish. And when we started the road trip from Alexandropolis to Thessalonica, and when we started the same road trip from Denizli, the island city in Turkey, Western Anatolia, you can see almost all geographical structure and also geography. So these are quite important. And when we check the Alexandropolis, around Alexandropolis, we can see some geothermal manifestos. And also near Thessalonica, again, we can meet some geothermal manifestos. It means that you have also great potentials. We believe that. And you are our komşu, and we understand that, and we follow that new supports from the European Union to Greece on geothermal energy. We are following very closely because we try to be part of them to help you and to support the geothermal energy around the world. And of course, we learned so many things about the geothermal power production, lesson learned, I mean. We did some mistakes, and we did some good things in geothermal power production, and these experiences are so vital for new investors in Turkey and also abroad and also in Greece. So it will be very nice to be support you for geothermal power production, and we also follow Lesbos tests, geothermal activities in Greece. And Turkey capacities, geothermal capacities and potential is of course different to each other. We are still trying to reach or unlock our geothermal potential for especially geothermal district heating and residential heating, greenhouse heating, and of course geothermal power plant product and geothermal power production. And we sure that it can be also possible for Greece, because agency is not only our common point. We have more than, especially for our tectonic structures and volcanoes and Hellenic structures, for example, just near the Marmaris and Izmir region, this is also our common tectonic activities. It's directly conclude the new geothermal capacities. And of course, besides the different residential heating and cooling options by geothermal fluids, heat pumps also another option. After the crisis between Ukraine and Russia, as you know, the Germany and some countries directly goes to heat pumps. And this will be very important for future, both for us, because the climate conditions going dry and hot, and the summers are long, and it directly affects Turkey and also Greece area. Yes, besides electricity production, of course, there are also many options, and you have also so many good foods, and this food drying is also one, will be important for your export and import issues. And besides the heating, cooling is also another option, as I said before, and cooling a little bit different and a little bit hard from geothermal fluids, because it requires twice flow rate, geothermal flow rate, but it is possible, and in Izmir region we have some examples, and we can also share if you interest in future. And thermal tourism, you are very familiar, and greenhouse are quite important for us. And when I go to surrounding of Greece each year, I feel happy because you use renewable energy more and more, especially for farms. You use solar PV system, and we try to see during the road trip the wind turbines, etc. But still, islands use diesel engine so for energy production. So we can also change it because we are very close to, for example, Çeşme region in Izmir. The kiosk is only away from the 8 kilometers from Izmir. In Çeşme region is very important place for wind power production, for example, and there are also geothermal fluids, geothermal activities, and kiosk is also similar activities. And I'm sure that one day kiosk also will use, for example, these renewables more widely, and it started by solar PVs. And the last issue I may mention today, the geothermal mining, and it's also important, especially energy storage topic, directly focus us to lithium production from the geothermal fluids, because it will be more clean than the extraction of the lithium bearing rocks to reach the geothermal lithium. So this is also one option for us. Of course, we have some experiences about exploration work. It starts with that, and you also that, because so many professors work on geothermal exploration when I was started the master degree, and they are still going these studies. And really, operations are quite important, and each operation is unique, and we must be very careful about the reservoir rocks, for example, and material and equipment production is also important, and operation and maintenance is another big issue for geothermal power plant, because you also will use water-dominated geothermal reservoir. It means that you will make so many thermodynamic changes, and it's directly affect the operation and maintenance issues. So we have also some experience, bad and good, and we will be very happy to share with you for possible cooperation. And Zorlu Energy is a member of the Geothermal Energy Association in Turkey, and there are also they also share some information with the government and try to improve the regulations to support the renewable energy. And especially the feed-in tariffs is quite important stage to growing of the geothermal system in Turkey. Thank you very much for your listening.
Thank you very much indeed. Very, very good presentation. One question I have for you. The 60,000 megawatt thermal, it's district heating. Okay. So it's according to the Energy Efficiency Directive to promote district heating and district cooling. Okay. And when is the period of time that you want that one to do it? I mean, 2030, 20?
It depends on the government.
On the government,
Yes,
yeah, depends on the government. Okay.
In Turkey, we generally use natural gas.
Yeah, yeah. And
the politics are quite important.
yeah, I got it. Yeah. That's a reason actually why you are first in Europe and fourth in the world regarding geothermal. Thank you very much indeed again. It was very presentation on a renewable that usually they don't have it on the front page. More sexy is wind and photovoltaics with usage factor of 0.2, 0.3 than geothermal with usage factor 0.9, 0.98. Okay. Yeah. Now the floor is for Dr. Iskander Gülkalp. I'm sorry about that. Marmara Research Center of Turkey. Thank you.
Okay. Well, good afternoon. Thank you for staying this long day. Thank you for the invitation to all. Well, we shall move to another topic. We mentioned the hydrogen in some of the presentations, but this will be kind of rapid, well, some arguments, both for hydrogen and also both for Turkey and Greece relationship. I will use this one. So this is all here. Let me go this way. So we shall start by mentioning a little some characteristics of the hydrogen. Well, you will see, and you know, in fact, in the region, we have what I called, but also our, the chairperson of IENE is just Kostis published or presented in a few weeks ago a paper where he relates also the lignite question to decarbonization, and we'll see why this is related to hydrogen. Well, we look to the networks, for gas networks, essentially from the Turkish side and Greece side, and then we shall say a few words about this. So hydrogen is indeed a nice molecule, as you know, but also a difficult one. Well, it is nice because it has indeed the decarbonization potential is high. As you know, it emits only water when it is converted to energy. It permits lots of decentralized energy strategies for multiple uses. For example, for islands, we mentioned also the islands today. And it has an important circular economy potential. We can generate, as you know, hydrogen from waste, organic waste. But at the same time, it's a difficult friend, let's say. It should be generated, of course. It is not natural gas. You cannot just dig and get it. And you can generate it by some technologies from various resources without emitting, well, greenhouse gases, essentially CO2. If not, the first point, the positive effect of the first point vanishes, of course, if you generate CO2 but when you produce hydrogen. It should be handled with great care. You know, it doesn't resemble at all to natural gas, even though natural gas has also four atoms of hydrogen. Its chemical and physical properties are totally different, and then it has a huge propensity to explode, to leak first, and to explode, and then generate fires, etc. And its transportation poses a problem also, as you know. It should be it can be transported, but only at high pressures or low temperatures, etc. So then you need lots of knowledge to deal with this. As I mentioned, I'm not sure if he's here, Kostis Stambolis, then I'm using his presentation a few weeks ago, in fact, on these decarbonization policies in Europe. I just put in red its arguments on this lignite question. As you know, indeed, the region is really full of coal, mostly lignite in Turkey also, and these are low-quality coals, as you know. So this should be somehow taken into account because it's an important asset of the whole region. And then you will see that we shall come down to hydrogen somehow, and there are some indications that the use of lignite or solid fuels in general may increase in power generation in coming years, which is of course just the opposite of the EU climate targets. But we know, on the other hand, that this economic asset is important for the region. Then it should be somehow reconciled with the COP28 commitments, especially, for example, we shall come back to that, by looking to these carbon capture options, etc. Well, in fact, just to summarize this, then we have today enough technological knowledge, scientific first, of course, and technological knowledge to use differently. I will put it here, I guess. Oh, well, this is also important. Look at the red thing. And no free money any longer for natural gas, but only for hydrogen, which is almost true. So then, how to harmonize? I'm not sure if it is the correct word, but at least the lignite question with decarbonization. Well, one should think we should remember, and I think we missed this a little during the day. Decarbonization does not concern only the power sector. This is the easiest part of the decarbonization. The renewables, indeed, with some storage, etc., may handle the decarbonization of the power sector. But what about the, as we say, difficult or hard to decarbonize sectors, the process sector, the aviation, civil aviation, fertilizers, etc.? So we need to, and you will see, in fact, and you know certainly, all the sectors, both to get decarbonized, but also to function, they need synthetic gas, meaning H2 plus CO, hydrogen, and CO2. Okay, so indeed, then the technology comes here a little late, but lignite gasification could be the bridging technology, bridging between this lignite question to use this asset of the region and to contribute to decarbonization. Yeah, for example, it is mentioned, you may know what is SAF, Sustainable Aviation Fuel. This absolutely needs the H2 plus CO, the synthetic gas. From there, you can go to SAF means, in fact, kerosene, but not fossil origin. Then you have to use some other organic materials to exactly obtain a fuel like kerosene. And the importance why we choose this. So in that case, you can use the same engines, aeronautical engines, the same logistics, etc. If we go directly to hydrogen, well, we change everything. and we don't have to do that. So we don't have time to do that. So we have to go through the stuff. E-fuels. E-fuels means CO2 plus hydrogen plus catalysis. And then you can go to any liquid fuel, etc. Then we need hydrogen and we need CO2. Then gasification is a nice way also to get this CO2. When you get this H2 plus CO synthetic gas, and then you can convert the CO into CO2, and you have to capture it, okay? So the idea is, the global idea is the last green words. Then gasification indeed probably is the only way to valorize in a bankable way the lignites of Turkey or the region. And then in that case, in fact, we are changing the nature or the value of this, indeed, a very badly burning, my field is combustion, I know that, it burns very difficultly. You have to put some diesel fuel or natural gas to burn it, to combust it. Then we change by this way, this asset to a new product, or new products, in fact, synthetic gas, CO2, hydrogen, etc., with higher values and with various markets and uses. And indeed, we know how to do it. This is a kind of not very old, but a previous EU program that I coordinated. Then we know how to convert to this thing. So the second point I would like to mention, and we are finishing rapidly, natural gas and hydrogen, they can each support each other in one way or the other. This explains this vice versa. So we need to find some ways, or ask the question, what is the best way for the cohabitation of these two gases, two molecules. The SIF approach, the sustainable fuel approach, is the one you understood. Then we generate the same fuel, kerosene, from not fossil resources, but from organic waste, etc., other organics. Then we can apply also this to natural gas with this e-fuel business. If we have CO2, hydrogen, clean green hydrogen, of course, or at least blue, to CH4, to methane. You know that natural gas is essentially methane. And then in that case, you do not change your infrastructures. You can use the same burners, the same gas turbines, etc. This is why I called it SIF approach. So keep all infrastructures unchanged. The tabula rasa, approach, Descartes, you may know, meaning that you restart. You go to pure hydrogen, okay, then dedicated pipelines, etc. And then you have to develop dedicated infrastructures, both for hydrogen logistics, storage, transport, etc., but also for the energy conversion. Today, a gas turbine that we are using with natural gas cannot work with hydrogen. A burner with hydrogen, with natural gas cannot burn hydrogen. So we have to change, but we know how to do it. It's a matter of time and investment, of course. And then finally, and then we shall finish with that, blending. The cohabitation with blending, both for the logistics, transport hydrogen blended in natural gas with the natural gas pipelines, and for the conversion also. Then in some cases, indeed, you can use the same combustors, let's put it generally like that, for this new blend. The big question, of course, for TSOs, etc., is what we call the gas quality question, meaning essentially what is the blending rate? Okay, you cannot have several blending rate in a given country, nor in Europe. You have to have probably one, but we'll see. Everybody is discussing on that. And also the question is, who will blend? So then to finish with, and we saw all this, hopefully, I mean, this came yesterday, so I'm using them. The infrastructure, gas infrastructure in Greece and in Turkey, then what we have to do, of course, is to somehow bridge these networks. We understood today that the KIPI is no more active. This is why I was asking this question. This is certainly the place to start with. Then in the Trakya region in Turkey, we have both on-ground natural gas. There are essentially Zorlu Energy, for example, and now TPA also extracting some natural gas. The Russian gas is coming to, as you know, to Kıyıköy, and also Turkey and others, Bulgaria and Romania also found natural gas in the Black Sea. So one approach would be indeed to blend hydrogen that you can generate through wind electricity in also Trakya, and then send this to, export this to Europe, or to at least to Eastern Europe. So two suggestions how to progress. Well, lignite business is important. I would like to see a kind of lignite gasification task force in Southeast Europe, and look at the right, taking inspiration from the Indian National Coal Gasification Mission. And you see the objectives they posed, and I recall also that India has a Ministry of Coal. Okay, and then the second idea, how to progress to, then establish a kind of Southeast Europe hydrogen in natural gas task force again. To do what? Well, to propose a kind of roadmap for hydrogen production targets, numbers in Trakya, Turkey. You have to settle the gas quality question, and then especially this rate of blending question, and develop jointly all these countries, Southeast Europe countries, the necessary technologies to use this new gas. As I mentioned, you cannot use the burners, the gas turbines using today natural gas with this blending. Then there is a lot to do all together. And thank you.
Thank you very much indeed. Professor, I would like to ask you, you propose, and I like it very much, a lignite gasification task force. I tell you the truth, I was working in India in a European project for promoting energy efficiency, and the big conflict that we had, it was with the Ministry of Coal. So they came and they were always, putting barriers to promote the energy efficiency directive in the different states. But nevertheless, we don't have that one here in our region. Do we have the theoretical background in that lignite gasification? Please. Yeah.
I showed it, this was a big European program.
Yes.
Joint program with India. Okay.
The FT, yes.
Yeah, exactly.
Yeah, the framework.
Absolutely. And then we, indeed, the system that I showed, it's a 1 megawatt thermal power plant working at 10 bars with the company, famous company Thermax.
Thermax, yeah,
exactly.
we know them. Yeah,
so we know, this is why I said we know how to do it.
We know.
Of course, it could be improved, etc.
Sure.
But we know. When I say we, not we,
yeah.
but the community.
Okay, just a minute, yeah. So therefore, that's a very good idea for IENE to see about that one and take some action, because we are working in the outlook, so probably this is one thing that we should look in the near future. So thank you very much indeed. So now we have the pleasure to have with us online Dr. Nicholas Koukouzas, a long-standing friend of us. Hello, Nicholas, how are you?
Yes.
Can you
Hello.
hear
I
us?
hope I can hear you very well. I hope that you can hear me as well, and you
Yes.
can see me.
Okay. Do you have a
Uh, so
presentation?
thank you. Yes, I have a presentation. I
Okay.
have a PowerPoint.
All
I'll
right.
try.
So the floor is yours then.
Thank you. Share screen then. I hope that you can see now my screen. So you can hear
Well,
me as
very
well.
well, yes.
Yes. So my presentation, unfortunately, is the last one, but I hope that you can survive. I will be very brief, and I would like to say a few words about hydrogen CCUS projects in Greece. I come from the Center for Research and Technology, ELAS, as a director of research, and we are doing some work not only research, but also related also to the industry on hydrogen and CCUS. So hydrogen, as the previous speaker said, is of interest for the private sector and public bodies. It's the energy source of today, and its ability to be stored in order to satisfy energy requirements. So in Europe, we have several projects like high under, high spray, high stir, related to geological storage in salt caverns or in porous formations. This is only related to geological storage, but of course we have projects related to infrastructure for CO2 capture and industry related to CO2 infrastructure and hydrogen transportation as well. So what I would like to say a few words about high stories. High stories, we participate as in this project. So that was 2 years projects between 2021 up to 2023, together with other European partners. We identify, this was in Horizon 2020, and we identified the places where we can store underground hydrogen, which is especially aquifers and depleted hydrocarbon fields in Europe. So from my experience, this is the first project, especially in Greece, but also in Europe, it's one of the first. So that we would like to go a little bit further on this because hydrogen storage is an essential part of energy storage nowadays. What about the rest of the hydrogen production? We have a White Dragon project this is a project of common interest. This is big, large, scale renewable electricity projects in Western Macedonia, together streaming through the DES natural gas pipeline. So you can see here some numbers related to the production, hydrogen production, saving of CO2, job creation, investment cost. This project is something that it's on hold for the time being, but we probably see it in the coming years. Another project related to this one, and as a complementary to White Dragon project, is the Green Hypo. So here we have the development, design, and manufacture of fuel cells for the heat and power generation. And again, Western Macedonia. Why Western Macedonia? Because this is probably a question coming to our mind. This is because, as the previous speaker said, we now go into the decarbonization of this area, where we have the big coal-fired power plants, lignite-fired power plants, and now the European Union goes to the Green Deal and green transition. That's why we go to this, let's say, green solutions to the area. So here again, we have some figures for the fuels, initial fuels capacity and job creation as well. Another project, which is just started related to hydrogen production is named Crave Hydrogen. So it's in Creta. where we have the full chain for hydrogen value is the production, the high pressure storage and dissemination. So we have not only the technology, but also social and environmental impact in the local communities, as well as design, permit, build and operate and trade hydrogen. So this is a big project again. So this is the first green hydrogen hub in Greece related to Atherinolakos area. So there we have an alkaline electrolyzer. We have fuel cell and we have hydrogen buses and reuse of water produced from fuel cells to partially cover the electrolyzer's requirement. Another one is named Hydrogen Hub, where we have, again, pilot application related to hydrogen production, storage, and utilization, where we have creation of a basic pilot unit operation scenarios, and to see the energy management, optimization of the installations, automation, and other things related to hydrogen production. And just not to go more on detail on that, we go to CCUS projects now. I just list some of the CCUS projects we have over the last years. So you see from 2010 up to now, probably you can recognize some of them. Leilak, for instance, is a project now, will have another 2 years. It's related to cement factory, and it's related to CO2 capture. Pilot strategy has another 2 years for geological storage. Consensus project is another one related to industrial plan for CO2 capture. So what is, just to finalize this presentation, what is going on now in the European Union? We move to renewables and decarbonization solutions. We increase hydrogen and CCUS application, and we create hydrogen and CCUS hubs. What is the positive motion towards hydrogen and CCUS in Greece is that we encourage the Greek government to set regulation policies and give also initiatives for hydrogen and CCUS applications in Greece. However, we need to have more regulations and more policies in order to have a better application of hydrogen and CCUS in Greece and in Europe. Thank you very much for your attention.
Thank you, Professor Koukouzas. I have a question for you two gentlemen, you professors, about hydrogen. I would like, if it's possible, to predict what's going to be the hydrogen in general, in all aspects, in 2030. Just to tell me, because you know how I started this one. A friend of mine that he's not an engineer, he told me, can you imagine hydrogen flowing inside the natural gas pipeline inside the cities? I'll go to my grandfather's village to stay. The people, they don't know it. I was trying to calm them down. They don't know, they're afraid. So you that you are experts, tell us, what's going to happen? What's going to be, I mean, the technology to prediction in 2030? Professor Iskan. Both of them, let's start from you.
Okay, all right. Well, in fact, you know that some years ago, in 60s, etc., Europe was using what? Town gas, manufactured gas. What is that? This is exactly kind of synthetic gas, CO plus H2. And then when essentially in the North Sea, they found, and then the UK converted in 10 years from 66 to 77, 19, 30 million of domestic appliances in 10 years to natural gas, okay? From town gas to natural gas. So two information, or two lessons from here. Then once we know somehow how to handle this hydrogen-containing fuel or gas or energy vector, and also a immense conversion or transition was possible in 10 years. Okay, in one country, but it was possible. Now we can say that Europe is one country.
You have the experience.
That's correct. So then let's work on it.
Dr. Kukovic.
I can tell you that 2030, as you put as a date, it's probably too close. It's only 6 years from now.
It's the first milestone. That's why I'm saying
It's the first milestone. But what is the situation now? It's a lot of projects, as I told you, and a lot of initiatives in European Union, the European Union related to hydrogen production and storage, transport and storage, and that's going to be the future. That's for sure. And that's everybody. I mean, they put a lot of money on that. So at least we can have the first hydrogen production, commercial hydrogen, hydrogen buses into 2030, and hydrogen storage, because we need specific sites for geological storage, because we will have a huge amount of hydrogen produced. So this is the case, but I'm not very optimistic that's going to be very fast. That's why I tell you that it's only 6 years from now. So probably I would put the target to 2050 to have more hydrogen in our energy portfolio and energy mix.
Thank you very much. Any question from the audience? Okay, we'll close it here. Thank you very much indeed, all of you. It was a very nice session, I think. Now, as they inform me, we have a photo session, all of us, and then Mr. Stambolis and Mr. Mustafa Teris, they have the closing remarks. Thank you very much indeed.
Thank you.
I'll take this and I'll give it